The morning air is cool and dry, and a faint mineral scent rises from the pale shore beside Owens Lake. In the first light, the Tufa towers stand quietly above the shallows, chalky and still, as if the water has only just withdrawn from them. You arrive in a valley that feels wide enough to hold old weather, with the Sierra Nevada far off, holding snow above the desert floor. These stone forms look almost assembled by hand, yet they began in a slower way, underwater, where springs moved up through lakebed sediment. Long ago, this basin held a much larger lake, fed by meltwater from colder seasons and distant ice. Beneath that surface, calcium-rich spring water met alkaline lake water, and dissolved minerals began to settle out, grain by grain. What now seems motionless was once part of a quiet chemistry, building soft crusts, hollow collars, and branching stone in dim green water. The dry towers before you are not the beginning of the story, but the exposed memory of an older shoreline. And if you stay with them for a while, the valley begins to reveal how water, mineral, and time slowly shape this silent edge of the basin. The first thing you notice, after the quiet, is that the towers do not stand at random. They gather in lines and clusters, as if they still remember where water once held them. Some rise in squat, pale mounds. Some lift in narrow columns with open throats and ragged rims. Some seem fused together, as though separate springs once worked side by side and slowly built a single stony wall between them. That pattern changes the question. It is no longer only how stone formed here. It becomes why it formed here, in these exact places, and why one tower grew broad while another remained delicate and hollow. To answer that, you have to look below the dry crust and the wind-bright surface. You have to imagine a lake much deeper than the one in front of you now. Not a sudden flood, and not a brief wet season, but a long inland water body held in the basin through colder spans of time. Snow gathered high in the Sierra Nevada. Ice endured longer in shaded ground. Spring thaw and summer melt-fed streams that carried fresh water eastward into the valley. Because the basin had no outlet to the sea, that water remained here. It spread, it deepened. It settled under a sky that must have looked wider still when reflected in such a lake. The exposed towers, for all their solid stillness, are the first clear sign that this valley used to contain much more water than it does now. And there is a second sign, quieter, but just as important. Tufa does not usually begin in open air. It forms where chemistry can meet in water. That means these chalky structures before you were made while submerged, hidden beneath a lake surface that has long since fallen away. So, the dry shoreline is already a kind of reveal. What you see as desert stone is really underwater architecture, left behind when the basin changed. That is the first escalation in the landscape itself. The towers are not ornaments beside the lake. They are evidence that the lake was once elsewhere and much higher and present for long enough to let mineral stone grow slowly around springs on the lake bed. If you remain standing at the shore, that fact alone begins to rearrange the valley. The pale flats no longer feel empty. They feel drained. The distance between the modern water and the old Tufa line becomes a measure of absence. And because the towers preserve that old level so clearly, the basin starts to read like a record instead of a scene. You can almost feel the story tilting backward. The mountain snow far to the west becomes more than scenery. It becomes the source of the lake that once covered this ground. The sediment beneath your feet becomes more than dust and clay. It becomes the floor through which spring water once rose. Even the rough skin of the towers begins to make sense. It is not carved decoration. It is accumulation. Thin mineral matter, precipitated again and again, until softness became shape, and shape became stone. A few steps closer, and the surface details sharpen. Small holes open through the pale walls. Knobs stack on knobs. Ribs curl around old vents. There are places where the tufa looks almost foamy, as if bubbles had hardened in place. Elsewhere it thickens into buttresses, heavy and rounded, with the weight of patient layering. These textures are not random weathering alone. They are clues to flow. Where water moved steadily upward through a spring mouth, a collar could build around the exit. Where small channels shifted, branching forms could spread outward. Where plants or reeds stood in the water, mineral coatings might gather over them, preserving a trace of something softer inside a harder shell. The valley offers you a choice here, though it does so quietly. You can stay with the outward appearance of the towers and let them remain strange white monuments in the desert light, or you can follow the process inward and try to see the hidden meeting that made them possible. The calmer choice, and the deeper one, is to stay with the process. So your attention moves down, not toward drama, but toward the buried spring paths under the old lake floor. Imagine the basin before these towers ever reached the air. Above them is greenish water, then rippled light, then sky. Below is soft sediment, rich with the fine material that settled out of streams and older lake cycles. Through that sediment, in scattered places, fresh groundwater is rising. It comes charged with dissolved calcium gathered from rock along its underground route. Around it, the lake water is different. It is more alkaline, richer in carbonate chemistry because the basin holds water without draining away, allowing dissolved ions to build over time as evaporation quietly removes pure water and leaves minerals behind. When those two waters meet, something changes. The dissolved components are no longer as comfortable together. Calcium and carbonate combine. A solid begins to form. Calcium carbonate settles out of solution in tiny amounts, not all at once, but persistently. That is the central mechanism, and it is gentle enough that the landscape can hide it in plain sight. No crash, no fracture, no eruption. Just the quiet threshold where one kind of water enters another, and invisible material becomes visible stone. Once that threshold is crossed at a spring mouth, the next consequence follows naturally. Anything sitting in the path of that mixing zone can become a surface for growth, a stem, a reed, a lump of sediment, the rim of a vent, a piece of earlier tufa. Each one offers a place where mineral can settle and stay. What begins as a thin coating becomes a thicker crust. What thickens can redirect flow. And when the flow shifts even slightly, new edges are created, and those edges invite more deposition. So the towers do not grow like trees from a single trunk upward. They assemble around pathways of water. A spring may first build a low ring. That ring may trap more mineral. Its walls may rise and split. A second nearby vent may start its own collar. Over many seasons, the forms can merge, branch, or leave hollow interiors where water once moved and then changed course. The shapes become more complex because the water beneath them is never perfectly constant. That variation is the next development the towers preserve. Not every spring in the old lake bed had the same discharge. Some rose more strongly, some were cooler, some carried slightly different loads of dissolved minerals depending on the rock they passed through underground. The lake water above them also varied with depth, temperature, and chemistry. So each tower records a local negotiation between moving groundwater and the larger body of the lake. That is why they resemble one another, but never repeat exactly. One spring might produce a broad, thick mass because the upwelling remained steady in one place for a very long time. Another might form a narrow chimney because the flow stayed concentrated through a smaller vent. A third might leave strange open cavities because water once passed through a framework of vegetation or fragile crust, and later abandoned it. The valley, which seems spare from a distance, now begins to feel crowded with hidden decisions made by water. A fracture in buried sediment could guide a spring upward. A patch of firmer ground could hold a vent in place. A subtle change in the lake level could shift where minerals settled most readily. Minute differences, repeated through centuries, become visible architecture. And this has another consequence for the way you read the shoreline. The towers are not simply markers of old water depth. They are maps of groundwater circulation. Each one points to a place where the lake floor once leaked fresh mineral-bearing water into the alkaline basin above it. The stone therefore records two systems at once. It remembers the surface lake, and it remembers the buried paths below. If you picture the ancient lake again, it grows more layered. At the top, wind moved across open water. Near shore, waves worked against sediment and shallows. Farther down, light softened. Then, at the bed, invisible fresh water rose from beneath, carrying chemistry from the subsurface into the basin. Where those layers touched, Tufa began. The longer the lake remained in place, the more opportunity there was for those small deposits to endure. And endurance matters here more than speed. A tower does not need dramatic growth. It needs continuity. A spring must keep rising. The lake must remain. The chemistry must stay favorable often enough that one thin crust can be followed by another, and another, and another. That requirement stretches the timescale almost immediately. Now you are not only looking at a local spring and a shallow margin, you are looking at cold, climatic intervals long enough to maintain a substantial inland lake in Owens Valley. During wetter and cooler periods of the Pleistocene, meltwater from snow and ice in the surrounding mountains fed the basin more fully. Evaporation still worked, as it always does in enclosed dryland valleys, but the balance had shifted. Enough water entered that the lake expanded. Enough remained that spring mouths stayed submerged. Enough stability held that carbonate stone could accumulate year after year without being interrupted too quickly by exposure and drying. This is where the towers begin to read less like isolated formations and more like the slow record of climate. Each layer of mineral suggests a moment when conditions held steady enough for growth. Each interruption, cavity, or textural change hints that the balance altered. Perhaps a spring weakened, perhaps the lake shallowed slightly, perhaps salinity crept upward as evaporation gained on inflow. Perhaps colder melt pulses from the Sierra refreshed part of the basin and changed the chemistry enough to alter the rate of deposition. None of these shifts needed to be abrupt to leave a mark. Slow variation is enough when the archive is built grain by grain. Standing beside the shore, you can almost reverse the exposure. The white dry stone becomes submerged again in your mind. The rough edges soften underwater. The open holes darken. Suspended particles drift through pale green light. Around each vent, mineral-rich water enters the lake, and a thin whitening crust forms where there had been none before. Then another, then another. A season passes, a century passes. The collar rises. Its center remains open where flow continues. Nearby, a separate vent starts its own low ring. The two structures expand towards one another, and in time they share a wall. At some points, the growing tufa traps small spaces within itself. At others, it breaks and reseals as spring discharge shifts slightly across the lake floor. Because the water that built it was always moving, the finished stone preserves motion without ever appearing to move. That is part of its calm power. Even now in the dry air, the towers seem active in a way most rock does not. Not because they are changing quickly, but because their forms are clearly the result of process. You can see the route by which they arrived. You can trace the upward emphasis of old vent mouths, the outward thickening of crust, the branching of once submerged edges. They are less like blocks and more like frozen circulation. The shore brightens as the sun rises higher, and the color of the basin shifts with it. What looked silver at first becomes pale tan and white. The water reflects a thinner blue. Dust and salt on the flats take on a soft glare. Against that brightness, the Tufa towers look even more improbable, as though the lake had receded only recently and left them still damp with memory. But that impression, too, leads to the next development. Exposure changes stone. Once lake level falls and growth surfaces enter open air, the chemistry that built them cannot continue in the same way. The mineral forms dry. Their pores whiten. Their outer surfaces weather under sun, wind, and salt. That means every tower carries two histories. First, the underwater history of formation, then the desert history of exposure. Before moving fully into that second life, though, it helps to linger inside the first one a little longer, because scale keeps widening. The old Lake Owens was not a shallow seasonal sheet. At times, it was part of a larger pattern of Great Basin lakes that expanded and contracted with glacial age climate shifts across the interior west. That wider setting matters because it explains why this one valley could sustain enough standing water for tufa to grow substantially. The Sierra Nevada, rising so sharply to the west, acted as both source and barrier. Snowfall accumulated in colder periods. Runoff descended eastward into closed basins. With no river carrying that water out to the ocean, the valley stored what climate delivered. So the towers at your feet are tied not only to local springs, but also to mountain snowpacks, storm tracks, temperature trends, and the long pacing of ice age weather. A broader climate pattern became a local spring vent. A distant cold season became a thin carbonate band. That chain of cause and effect is one of the quietest in geology and one of the most complete. Clouds gather over mountains. Snow remains. Meltwater fills streams. A basin lake deepens. Groundwater rises through sediment. Alkaline and calcium-rich waters meet. Stone forms underwater. The lake later declines. The tower stands dry in morning light. Nothing in that sequence is rushed. And because nothing is rushed, almost every part leaves some trace. Even the textures that seem decorative are practical records. A bulbous swelling may indicate persistent deposition around a stable spring mouth. A more delicate and porous wall may suggest slower growth over a framework that included organic matter. A hollow tube may preserve the path where water once moved centrally before the vent shifted or sealed. A broken rim may show where later exposure and weathering trimmed what underwater growth first assembled. The more closely you look, the more the stone stops behaving like a finished object. It becomes a conversation between duration and change. By now the valley has done what quiet landscapes often do. It has replaced the need for spectacle with the need for attention. Nothing here insists. The towers do not explain themselves. The lake does not recreate its former depth for you. The Sierra does not send down visible rivers in this moment to prove its old contribution. Instead, each part offers a small certainty and asks you to connect them patiently. The certainty of mineral stone, the certainty of an enclosed basin, the certainty of changing lake levels. Put together, they make the pale towers almost inevitable, yet their exact shapes remain singular. That tension between rule and variation is part of what keeps the place alive. You understand the process, but not every contour. You know why tufa could form here, but not why one lip curled just so, or why one chamber remained open while another sealed. Some details belong to lost flows too fine to recover. That partial mystery gives the formations a kind of softness. Science clarifies them, but does not exhaust them. And as the morning light reaches farther across the alkali margin, another thought begins to settle in. For all the time needed to build them, the towers depended on a condition that would not last forever. Lake level had to remain high enough to keep the spring mouths submerged. If climate shifted toward drier warmth, or inflow weakened over long intervals, the balance would change. The shoreline would move. Water would pull away from places where it had once lingered for centuries. Growth would slow, then stop in open air. That turning point does not arrive like a disaster. It arrives as a lowering, a gradual loss of depth around structures that had only ever known submergence. And once the lake begins to withdraw, the meaning of the towers changes with it. They cease to be active construction sites of mineral chemistry and begin their second existence as exposed records beside a shrinking basin. The next step in the story lies there, where old underwater forms first met sun, wind, and drying air, and where the quiet architecture of the lake became visible land. The first effect of that exposure would have been simple and almost tender. Water that once pressed lightly against the tufa no longer covered it. The upper rims emerged first, then the shoulders, then whole chimneys and knotted masses stood in air, carrying lake water in their pores for a while, before the desert took that moisture back. What had formed in filtered green light now met direct sun. That change sounds small when said quickly, but for the stone, it meant an entirely new environment. Underwater, temperature had shifted slowly. In open air, surfaces warmed by day and cooled sharply after sunset. Underwater, fine suspended matter drifted around the towers. In air, wind brought dust, salt, and dry abrasion. Underwater, mineral growth had depended on constant contact between spring water and alkaline lake water. Once exposed, those same surfaces could no longer continue in the same submerged rhythm. The chemistry did not vanish from the basin, but the location of active growth changed with the retreating shoreline. That is why the towers are so revealing. They show not only where the old lake stood, but where it no longer stood. Each exposed band is a quiet marker of falling water. Each dry chamber suggests that a vent once worked below a surface that has since withdrawn. The tufa did not move. The lake did. And because the towers remained where they had formed, the recession of the water became legible across the basin. A person standing here now can read a kind of absence in reverse. The pale structures nearest modern water are one clue. Those stranded farther out on the flats are another. Together they suggest a shoreline that paused, shifted, and stepped away over long intervals, not always evenly but persistently enough to change the role of the entire landscape. That shift from submerged growth to exposed archive was not a single event. It happened in stages. Some springs would have stayed underwater longer than others. Some towers might have continued to accrete mineral near their bases while their upper portions had already dried. In places where groundwater still rose and shallow water lingered, new crusts could form for a time. Elsewhere, growth stopped almost completely as soon as the lake margin retreated, so even the end of formation was uneven. There was no universal stopping moment for all tufa across the basin. There were instead many local endings, tied to small differences in elevation, spring discharge, and the changing geometry of the shore. That unevenness matters because it left different kinds of evidence behind. A tower exposed early might weather longer, whitening and roughening under the desert sky. A tower exposed later might preserve finer textures because its underwater surfaces spent less time in open air. A formation still touched by intermittent shallows could carry both stories at once: older subaqueous growth below, newer signs of drying and salt above. In that way, the basin did not simply lose a lake. It developed a layered margin where geology and climate could be read together. As the waterline lowered, the broad shape of Owens Valley became easier to understand from the ground. This is a closed basin held between ranges, with the Sierra Nevada to the west and drier highlands beyond. That topography had once allowed water to gather and remain. Now it also shaped how the remnant lake and alkali flats spread across the lowest ground. The shrinking shoreline did not leave a neat edge. It left muds, mineral crusts, shallow pools, and a widening zone of exposed sediment. Into that new zone, the Tufa towers stood like old posts from a former world. Their pale color would have grown more obvious as they dried. Calcium carbonate can weather to a chalky brightness. Dust can settle in its cavities. Salts can collect in sheltered hollows. The result is the whitened, porous appearance that catches morning light so softly today. Yet even that bright dryness is not a loss of information. It is another stage in the record. Exposure changed the towers, but it also made them visible. A structure hidden underwater is hard to inspect in full. A structure standing in open desert light can be circled, compared, measured, and read. The same retreat that ended one kind of growth also opened the archive. That is one of the quiet reversals in this landscape. Decline in water level preserved knowledge. The lake had to recede before its former chemistry could become landform. And once that happened, the tufa began to participate in a different set of slow processes. Sun entered its pores, wind scoured its outer skin, cold nights and hot days stressed its surface a little at a time. Dust from the basin settled into crevices. Fine salts moved with moisture and dried again. Each of these changes was gentler than a wave. but over long periods they mattered. A soft tower might become more friable near its rim. A cavity once kept damp could dry and crack along a thin bridge. A base could gather sediment until part of its lower contour disappeared into the flats. In some places, weathering exaggerates the original form. In others, it blurs it. A vent once rounded underwater may become sharper when softer material is removed from around it. A delicate flange may crumble away and leave only a thick stub. So the present shape of any tower is always a collaboration between formation and afterlife. You are never seeing pure growth alone. You are seeing growth, then exposure, then weathering, all layered into one object. That layered history becomes even clearer when you think about the lake margin during drier phases. As Owens Lake contracted, evaporation would have concentrated dissolved minerals more strongly in the remaining water. Shallow zones near the edge could become especially saline and alkaline. Mudflats would dry and re-wet with seasonal changes. Fine sediments could crust, crack, and then soften again under brief moisture. That matters for the Tufa, because the ground around it was not inert. The towers stood in a basin surface that itself was shifting chemically and physically. Evaporite minerals, including salts left behind by drying water, could accumulate in nearby sediments. Wind could then mobilize some of that fine material and bring it into contact with the tufa. The towers therefore sat within a broader mineral environment, not apart from it. Their bases could be partly buried by new deposits. Their lower flanks might collect dust and salts that changed their appearance. Their outlines against the flats could sharpen or soften depending on what the basin floor was doing around them. This gives the exposed tufa a new kind of agency in the landscape, though not an active one. It shapes how sediment settles at small scales. A tower interrupts wind near the ground. It creates sheltered pockets where fine grains can collect. It casts shade, brief but real, changing temperature and moisture in the few inches besides its base. Even a low mound of porous carbonate can influence how crust forms around it. Over many seasons, those small effects help determine whether a base remains clearly exposed or becomes partly merged with surrounding sediment. So after the lake withdrew, the tufa did not become irrelevant to process. It simply entered a different network of cause and effect. The same is true if you widen the view beyond any single tower. As more of the former lake bed emerged, the valley must have looked less like one continuous water surface and more like a mosaic. Open water remained in lower areas. Shallow margins spread and retreated. Mud flats brightened as they dried. Spring-fed spots persisted in places. Tufa lines marked former conditions the newer basin no longer matched. This patchwork would have made the changing shoreline hard to define as one sharp boundary. Instead, it would have been a broad zone of transition, where submergence gave way gradually to exposure. And in that broad zone, the tufa became the clearest fixed element. Water changed shape around them, light changed across them, seasonal conditions came and went. But the towers held position, and because they held position, they could preserve relation. A tower's height above modern water means something. Its distance from remaining shoreline means something. The basin speaks through those differences. There is also a deeper reason the exposed towers feel so quiet. They no longer participate in the moving water system that created them at full strength. A spring may still rise somewhere nearby. Groundwater still exists in the valley. Seasonal moisture still touches the basin, but the enclosing lake that once completed the chemistry around these exact forms is gone. That missing half of the process gives the towers their silence. They are not unfinished in the ordinary sense. They are interrupted. Their architecture belongs to a set of conditions that withdrew before the forms themselves disappeared. That is why standing among them can feel like standing inside a paused sentence. The grammar is still present. The ending changed. If you kneel near one of the lower mounds, the stone reveals this interruption in intimate detail. Its surface is rough, but not random. Small rounded protrusions suggest mineral buildup around old flow edges. Tiny cavities hint at spaces where water once moved, or where organic material became coated and later decayed. Thin, layered crusts can sometimes be traced where one depositional phase gave way to another. These are underwater signatures preserved in open air. The remarkable thing is not only that they survived, it is that they remain interpretable after so much change around them. The reason has to do with the durability of carbonate once formed, and with the relative gentleness of many desert weathering processes over moderate spans. Yes, tufa is softer and more porous than dense limestone. Yes, it can be worn, broken, and altered. But in a dry basin where burial, exposure, and abrasion happen gradually, broad forms can persist for very long periods. That persistence allows the towers to bridge timescales. They reach from seasonal dust and daylight all the way back to glacial age water. Very few landforms do that so clearly at hand scale. A mountain records long history, but often too broadly to feel intimate. A sand dune records wind, but often too restlessly to preserve one old state. Tufa sits in a middle ground. It is local enough to inspect closely. It is old enough to carry climate memory. And because it formed from water in a now drier setting, it naturally invites comparison between then and now. The Sierra Nevada helps sharpen that comparison. Look west, and the mountain wall explains the past without speaking. Those heights gathered the snowpack that sustained inflow during colder periods. Streams descending from those mountains fed the basin in ways that changed with climate. When colder, wetter conditions prevailed, the valley retained more water. When warmer, drier conditions strengthened over time, the lake receded. So the mountains and the towers belong to the same story, even though one seems permanent and the other fragile. Snowfall in granite country helped build carbonate structures in alkaline water below. That chain is long but direct, and once the lake began withdrawing, the mountains continued to matter. Reduced inflow did not only lower water level, it also altered lake chemistry. As volume declined, dissolved materials in the remaining water could become more concentrated. Shallower margins warmed more easily. Mixing patterns changed. The relation between spring mouths and the surrounding lake water shifted as depth decreased. This means the final phases of tufa formation before full exposure may have been chemically distinct from earlier phases during higher lake stands. A spring that once discharged into deeper, relatively buffered water might later enter shallower, more concentrated conditions. That could affect how quickly carbonate precipitated, where it accumulated, and whether a vent remained open. So the very end of underwater growth may be recorded in subtle differences of texture near exposed upper surfaces. A crust may become denser or more irregular. A rim may narrow. A cavity may seal. These are small clues, but they fit the larger pattern. Retreating water did not merely reveal towers. It changed the conditions at their edges before revealing them. In that sense, the lake's withdrawal wrote one last chapter into the stone before leaving it behind. What followed on land was slower, but not insignificant. Wind is especially important in Owens Valley. The valley can channel air, and the basin floor offers abundant fine sediment. Over long spans, wind-blown particles abrade exposed surfaces lightly, settling into pores or being removed again. Where a tower has a windward side and a sheltered side, those micro differences can matter. A cavity facing prevailing winds may fill with dust sooner than one turned away. A thin projecting lip may break faster if repeatedly dried, heated, cooled, and touched by moving grit. Even so, the pace remains calm. Nothing about this change is violent in the scale that matters here. It is patience meeting patience. Stone, made slowly, is altered slowly. That pace is what lets the valley preserve both process and atmosphere. You can feel that if you imagine the same tower over many thousands of years after exposure. At first it dries. Then its pores brighten with salt and dust. A little edge breaks. Sediment gathers at its feet. A neighboring patch of shoreline shifts. A wet season briefly darkens the base. A long dry interval leaves a powdering crust. Through all of this, the tower remains recognizably itself. The original underwater shape continues to dominate the silhouette, and because the silhouette persists, the ancient lake remains legible in the present day. There is a kind of mercy in that. Many natural records are erased as soon as conditions change. A shoreline can vanish, a channel can fill, a spring can move and leave little trace. But Tufa turns one set of waters into a form substantial enough to endure after the water is gone. It is memory mineralized, not complete memory, because no archive is complete, but enough memory to hold the broad truth. There was a lake here. It stood higher. Groundwater rose through the floor. Chemistry built these forms underwater. Then the lake withdrew. The air took over. That sequence is simple enough to say in one breath, yet it contains climate, hydrology, geology, and time. Now, in the exposed basin, those large forces feel gathered into pale, quiet shapes. The more you stay with them, the more the whole valley begins to arrange itself around water that is not fully visible anymore. Some water has gone into the past lake, some still moves underground, some remains in shallow modern water, some returns seasonally as runoff or brief pooling. The tufa belongs to all of these states at once. It would not exist without past abundance. It endures because of present dryness, and its textures still imply hidden movement below the surface, because springs once chose these places with remarkable precision. That hidden precision can be seen when towers cluster along subtle lines. Those lines may reflect buried fractures, permeable pathways, or spring zones beneath the former lakebed. The stone therefore maps structure in the sediments below. Exposure did not create that map. It revealed it. A dry observer can now infer where fresh water once entered the alkaline lake simply by following the arrangement of tufa across the flats. This is another reason the towers feel less like isolated sculptures and more like evidence. They carry spatial logic. They tell you where the basin breathed. If you move outward through the old shoreline zone in your mind, from one tower field to another, the valley grows more coherent. A low area gathered lake water. Beneath it, groundwater found pathways upward. Where those pathways were stable and chemistry favorable, carbonate accumulated. Where lake level remained high for long enough, growth became substantial. Where water later receded, the resulting forms were stranded. Each step follows the last, and because each step depends on ordinary physical processes rather than rare catastrophe, the final landscape feels deeply plausible. That plausibility is part of its peace. Nothing here seems forced. The basin did what closed basins do. The mountains did what snow-bearing mountains do. The springs did what groundwater under pressure often does. The chemistry did what calcium and carbonate do when conditions align. The extraordinary appearance of the towers comes from the duration of those ordinary things. Duration is the sculptor. By late morning, sunlight can flatten color in the alkali basin, turning distance into brightness and surface texture into a glare-softened field. Under that light, the tufa often appears almost weightless, though it is stone. Its pale walls can resemble bone, coral, or old plaster, depending on angle and distance. That visual strangeness has probably always invited comparison. Yet the longer you spend with the towers, the less foreign they seem. They begin to look exactly like what they are, accumulated mineral at the old meeting points of water. Their weirdness resolves into logic. And once that happens, another part of the basin comes forward. The spaces between towers start to matter. Those open intervals are not empty stage floor. They are former lake bed, exposure surface, sediment trap, salt plain, and occasional habitat all at once. The towers are dramatic only because the surrounding ground is so restrained. Flatness makes relief visible. Silence makes texture audible to the eye. A low mound of carbonate seems monumental when it rises from broad, level brightness. That relation between form and emptiness will matter even more as the day in this story moves on, because life in the basin now arranges itself around those same contrasts. Even in stark places, roughness invites company. Shade matters, moisture matters. a little shelter matters. And the tufa, though ancient and mineral, still provides those things in small ways. But before the living present gathers fully into view, there is one more quiet expansion of the older story. The exposed towers of Owens Valley are not isolated from the history of the wider interior West. They belong to the much larger pattern of pluvial lakes that filled Great Basin depressions during cooler and wetter phases of the Pleistocene. That regional pattern gives the local stone an added scale. Owens Lake was one expression of a continental climate rhythm. Elsewhere, other basins also deepened, shrank, left shorelines, and preserved mineral evidence of changing water balance. When scientists compare these records across basins, they can trace broad synchronies and local differences. One valley may show a lake high stand at a certain interval, another may reveal different timing or chemistry. Together, those comparisons help reconstruct how moisture, temperature, and atmospheric circulation shifted over thousands of years. The tufa of Owens Valley therefore stands at two levels. It is deeply local, tied to individual spring mouths in one basin, and it is regionally significant, tied to glacial climate dynamics across a large landscape. That doubleness gives it unusual richness. A child can see a tower and wonder how it formed. A geologist can sample it and ask what it says about lake chemistry, isotopes, and paleoclimate. Both are attending to the same stone. The difference is only the scale of the question, and because the stone preserves shape so well, the questions can move back and forth between visible form and hidden process. Why is one tower thick? Perhaps a vent remained stable. Why is another porous and branching? Perhaps flow spread through vegetation or along multiple small outlets. Why are towers exposed here at this elevation? Because lake level later fell below them. Why did the lake fall? Because climate and hydrology shifted over long periods. Every local feature opens outward. Every broad pattern returns to a local feature. That rhythm of expansion and return is one of the basin's gifts. It never leaves you only in abstraction. There is always a surface to touch with the eyes. Now the present-day shoreline begins to matter more clearly. Where shallow water still lingers, or where remnant wet areas form seasonally, the old tufa fields sit near modern ecological edges. Those edges are sparse compared with a lush marsh or forest, but they are not empty. Open sky, briny water, alkali flats, and rough carbonate together create a quiet living landscape. The tufa no longer grows as it once did. Still, it remains involved. It alters light and shade. It catches wind differently than flat mud does. It offers little ledges, pockets, and cooler spaces at ground level. Tiny things notice such differences, even if a casual passerby does not. This is where the story gently turns from afterlife in stone to afterlife in place. The lake withdrew, yes. But the basin did not become lifeless. It changed mode. What was once a broad inland water body became a more austere arrangement of shallow water, salt, sediment, air, and intermittent abundance. Now the details become smaller, and because they become smaller, the basin begins to feel more inhabited. A flat of salt and mud can seem empty from a distance, yet up close it separates into slight elevations, damp margins, crusted hollows, and thin films of water. Each of those conditions holds moisture differently. Each receives light differently. Each changes the ground temperature by a little. Those little differences are enough to organize the present landscape. A tufa tower, even a low broken one, interrupts that simplicity. Its porous walls cast narrow shade in the morning. Its cavities keep cool air for a little longer after sunrise. Its rough surface catches dew, dust, and tiny drifting material. A smooth alkali flat offers almost nowhere to pause. A rough carbonate mound offers many such places. That is the first quiet ecological consequence of old geology. The stone does not create abundance. It creates variation. And in austere places, variation matters more than plenty. If you remain at the lakeshore through the morning, you begin to notice how spare life gathers by edges. A shallow pool close to the tufa may carry a thin green or reddish film of microbes. On another patch of damp sediment, salt-tolerant algae stain the ground softly. Along a slightly raised margin where salinity is lower for part of the year, low plants can hold on in scattered tufts. None of this fills the basin, it only touches it. But the touch is enough to change how the place feels. The stone, the salt, and the water are no longer separate scenes. They are parts of one arrangement. That arrangement depends on a chemistry as patient as the one that built the tufa. Owens Lake water, where it remains or returns seasonally, can be highly alkaline and saline. Those dissolved salts limit which organisms can live easily in open water and on wet mud. Yet limitation is not absence. Some microbes are well suited to such water. They can tolerate high salt concentrations, shifting temperatures, and intense sunlight reflected from bright flats. They spread in films so thin you might overlook them, though they are often the basin's most constant life. These microbial communities matter in ways that are easy to miss. They stabilize tiny patches of sediment. They change the color of wet surfaces. They participate in the cycling of carbon and other elements in shallow sunlit water, and because they occupy the exact places where moisture lingers longest, they become part of the visual grammar of the shore. White crust, grey mud, a faint green sheen, a rust-red margin, pale tufa beyond. The whole basin reads in muted tones, but each tone has a cause. The rougher surfaces of tufa can support these minute differences in their own way. Moisture held in a protected cavity may last a little longer after night cooling. Wind may dry the outer wall quickly, while an inner recess remains damp for an hour more. Dust caught in a crack can mix with mineral fragments and create a tiny pocket where a seed might settle, though not often and not for long. A spider may find a shaded angle. An insect may rest out of the wind. These are very small acts of shelter, yet they are part of the tufa's afterlife. The stone that once formed around rising spring water now influences the present by changing texture and microclimate at ground level. Birds make that connection easier to see. In a broad alkali basin, open water and shallow margins draw them in ways that dry flats alone do not. Where seasonal pools persist, or where remnant water offers feeding grounds, birds arrive to use what the chemistry of the lake permits. Some probe wet sediment, some skim or dabble in shallows, some simply stand in bright stillness, as if they too are reading the old shoreline. The tufa towers are not their main reason for being here. Water is. Still, the towers alter the shoreline enough that birds move among them, around them, and sometimes beside them. A broken tufa block near a pool can create a slight wind shadow. A tower line may mark firmer footing in a muddy edge. From a little distance, pale birds among pale stone can seem like part of the same mineral light. The basin's living present remains delicate, but it is unmistakable once you learn where to look. This is the reveal of the modern landscape. The tufa is not only a remnant of vanished water, it still participates in present conditions. Its roughness stores shadow. Its pores hold traces of moisture. Its shape redirects drifting sediment. It gives the eye a fixed point and gives tiny forms of life a slight adjustment in the ground around it. That influence is modest, never lush, never busy. But modest influence can be the defining kind in a place this spare. The day itself helps show that. At dawn, the stone looks cool, almost blue-gray in the valley's first light. As the sun rises, its pale carbonate surface begins to reflect more brightness, and the towers can seem to glow without color. By midday, the alkali flats around them grow stark. Heat rises from the ground. Shadows shrink into tight, dark crescents at the base of every projection. It is during those hours that the tufa's smallest shaded hollows matter most, because the rest of the basin can become nearly uniform in glare and warmth. Then, toward evening, the relation changes again. Long shadows stretch out from the towers. The whiteness softens. Dust in the air turns light golden, then rose-colored, then faintly gray. A place that felt almost abstract at noon becomes dimensional again. Those daily changes do not alter the geological meaning of the tufa, they alter its ecological and visual presence. The same wall of carbonate can be harshly bright at midday, then gentle by dusk. A cavity that looked empty at noon may hold coolness at sunset. A shallow pool that vanished in glare reappears as a mirror. When light changes, the basin's sparse life becomes easier to sense. This is why one day at Owens Lake can quietly echo the much longer hydrologic story of the valley. Morning moisture, midday concentration, evening release, small daily rhythms resemble, in miniature, the larger balance of water gain and water loss. Not as a direct copy, but as a familiar motion. Water gathers, water lingers, water thins. What remains becomes more concentrated. That is true in a shallow seasonal pool. It was also true over far longer spans in the larger life of Lake Owens itself. Once you notice that rhythm, the basin seems less divided between past and present. Seasonal and daily changes in the modern shore feel like reduced versions of the same processes that once governed the ancient lake. A winter storm in the mountains can send a pulse of runoff down into the valley. Snowmelt can alter inflow patterns over a season. A wet year can expand shallow habitat. A dry one can contract it sharply. Mudflats that held water for weeks may harden and whiten. Microbial films may spread, then disappear. Brine concentrations may shift enough to change where insects gather. Bird use follows that variability. Plants at the margins respond to it as well. Nothing in the current basin is fixed for long except the broader geometry of the land. And the tufa itself, that contrast gives the stone its special calm. Around it, water comes and goes. Salt crusts thicken and break. Surface colors change with moisture. Living things arrive in pulses, then move on. The towers remain not unchanged, but slow enough that they feel steady against everything else. The ecology of the basin therefore gathers around an ancient anchor. You can think of the tufa as a kind of rough punctuation in a sentence otherwise written in flats, shallows, and sky. It does not dominate the meaning, it clarifies it. A smooth shoreline can feel temporary because every line is soft and movable. A tower fixes memory into place. It tells you that this edge has a depth of time not visible in the water alone. And because it fixes memory, the present ecosystem inherits that memory as structure. The same tower that records an old spring vent now hosts tiny patches of shade, catches wind-blown organic matter, and marks a transition between open flat and raised relief. A slight rise is enough for a plant to avoid standing brine for part of the season. A cavity is enough for a small arthropod to rest. A rough ledge is enough to interrupt the uniformity of heat. Scale stays small, but consequences remain real. The basin's living pattern also depends on the chemistry of what is dissolved and what precipitates out. When saline or alkaline water becomes shallower, evaporation increases the concentration of dissolved ions. At a certain point, minerals can begin to crystallize at the surface or in shallow sediment. That process changes the texture of the shore. A soft margin can harden with crust. Then a brief wetting can soften it again. As crusts form and dissolve, habitat shifts. Invertebrates that use wet edges may lose one patch and gain another. Microbial mats may thrive where salinity is high but not too high, then recede when the balance changes. The present ecosystem is therefore inseparable from the same water chemistry that shaped the ancient one. Only the products are different now. Then, carbonate built underwater structures around springs. Now, salts and surface moisture patterns help define the modern basin's sparse biological zones. The continuity is subtle but deep. Water still sorts the valley by chemistry. Minerals still respond. Life still arranges itself accordingly. And because the climate of Owens Valley can swing between cooler nights and bright, dry days, daily stress and relief create another layer of change. A pocket of moisture in the morning can evaporate by noon. A plant rooted where groundwater influence is just slightly greater can remain green longer than another a few feet away. A microbial film exposed by receding water may brighten darken, or crack depending on the hour. The same sensitivity that once let thin carbonate bands record tiny environmental shifts now helps modern surfaces register short-term ones. This does not make the basin fragile in the dramatic sense. It makes it responsive. Everything here is tuned to thresholds. How salty, how wet, how warm, how long the water remains, how deep the shade falls, how far a seed lands from a rough wall that can shelter it. The tufa fields fit naturally into that threshold landscape because they are threshold objects themselves. They formed where one kind of water met another. They now persist where dry land and remnant lakes still trade places at the margins. The movement of wind deserves its own attention. In such an open valley, even a gentle breeze can transform perception. Across the flats it carries fine dust, cools the skin, roughens shallow water, and leaves the towers standing in a faint moving haze. For the ecosystem, wind redistributes material constantly. It can move salt-rich particles across short distances. It can heap fine sediment against the lee side of a tower. It can expose one patch of damp mud and bury another in powdery dust. These changes are not random noise. They help determine where moisture persists and where it vanishes quickly. A little sediment piled in a sheltered spot may hold water differently after a brief wetting event. A scraped patch may crust faster. Tufa, by standing above the flats, participates in that sorting. It is not only shaped by wind, it organizes wind at very small scales. That is one reason the stone continues to matter after its own formation has ended. The ecosystem's quietness becomes most apparent when you resist the urge to look for abundance in the usual forms. There are no dense forests here, no broad reeds swallowing the shoreline, no lush marsh calling attention to itself. Instead, life appears in margins, in films, in passing wings, in slight color changes, in occasional movement close to the ground. The basin asks you to recognize persistence without spectacle. That way of looking suits Tufa very well. The stone itself is evidence of persistence without spectacle, so the present ecology feels like an extension of the same lesson. A bird stepping through a shallow briny edge, a thin line of salt-tolerant vegetation, a dark microbial stain in a wet depression, these are not separate from the Tufa's story. They are what remains when water becomes less abundant, but still governs everything. That continuity also widens the emotional scale of the valley. At first, the Tufa seems to belong entirely to the past. Then you realize it still acts in the present. At first, the modern basin seems too spare to hold much life. Then you notice that spareness is simply the visible result of strong chemical filtering. What can live here has to fit the water. What can grow here has to fit the salt. What can persist here has to fit the rhythm of wetting and drying. Those are the same kinds of constraints that once controlled tufa growth. The present is therefore not an unrelated sequel. It is the same hydrologic setting, reduced, altered, and still at work. By late afternoon, if the light softens and the valley wind relaxes, the towers can seem almost companionable. They stop appearing as strange objects in empty space. They become part of a lived shoreline, even if the life is quiet enough to miss at first glance. A small bird crosses the flats. A shallow pool reflects cloud and mountain. A patch of salt sparkles briefly, then dulls. One side of a tower warms in the last sun while the other enters cool shadow. The basin's stillness deepens, but so does its complexity. All day long, water has been deciding where things can happen, where a film can remain, where a crust can form, where an insect can gather, where a plant can root for one more season, where a bird can feed in the thinnest margin between open water and solid ground. And the tufa, standing at those decisions, keeps reminding you that such sorting has been going on here for a very long time. That long view becomes even clearer when you return your attention from the surrounding life to the stone itself. A porous wall is not just rough to the touch of the eye, it is layered evidence. Its outer skin may hold traces of desert exposure, its interior may preserve cavities from underwater flow. Its position above the current lake margin may indicate a former stand of water. If a tower line sits at one elevation and another line lies lower, the basin hints at more than one phase of shoreline stability. So even while birds move through the present and microbes color the wet edges, the tufa continues to invite a different kind of reading. It asks to be interpreted. That interpretive turn is the next deepening of the story. The stone is not only beautiful and not only ecologically relevant, it is also a climate archive. Its texture, composition, and placement carry clues about when the lake was fuller, how long it stayed that way, and what kind of water chemistry prevailed while the towers were forming. This is where visible form begins to open into evidence. A cavity in tufa is not proof of only one thing, but it may suggest a path of spring flow or mineral coating around organic matter, or a later stage of weathering after exposure. A band of denser carbonate may indicate a shift in deposition conditions. A broad buttress may imply sustained discharge from a stable vent. A tower's height relative to others may reflect local spring behavior and the changing level of the lake around it. No single feature gives the whole history, but together, features begin to assemble a climate story in mineral form. Scientists often read such archives by combining what the eye can see with what careful measurement can reveal. The visible part comes first. Where is the tufa located in relation to present and former shorelines? How porous is it? How layered? How massive? How strongly weathered? Does it occur in isolated towers, encrusting ridges, or clustered spring mounds? Are there signs that different growth phases overlap? These observations help build a map of old conditions. Then samples can go further. The carbonate itself may preserve isotopic signals, subtle chemical ratios that formed under particular water temperatures, sources, and evaporation conditions. In simple terms, the stone can retain a fingerprint of the water from which it precipitated. That does not mean it tells an effortless story. Interpretation always takes care. Later alteration can complicate the signal. Exposure can change surfaces. Groundwater can move through old pores. Yet enough original information often remains that the tufa still speaks quietly but clearly about the vanished lake. The importance of isotopes lies in their gentleness. They are not dramatic markers. They are tiny differences in atomic form, sorted by physical and chemical processes as water moves through the world. A change in temperature, a different source of water, stronger evaporation, or altered mixing can shift those ratios slightly. When carbonate precipitates, it may capture some of that pattern. So a piece of tufa can preserve evidence not just that water existed, but what kind of hydrologic setting that water represented. In Owens Valley, this matters because the lake's history was tied to glacial age climate. More snow in the Sierra, cooler temperatures, different storm tracks, and changing evaporation all help determine whether the basin held a large lake or a reduced one. Tufa formed during intervals when local spring chemistry and lake conditions lined up long enough to build carbonate structures. If you can date those intervals and analyze the carbonate, the towers begin to anchor larger climate reconstructions. That is the next reveal. What looked like a local oddity, white spires in a desert basin, becomes part of a regional record of the Pleistocene West. The same cold and wet phases that expanded lakes elsewhere in the Great Basin also influenced Lake Owens. The same warming and drying that reduced inland waters across the region eventually exposed these towers. By comparing tufa ages and chemistry from Owens Valley with shorelines, sediment cores, and other basin records nearby, researchers can ask bigger questions. When were lake high stands most stable? How synchronously did closed basins respond to climate shifts? How much of a change came from increased moisture, and how much from reduced evaporation under cooler temperatures? How did meltwater pulses from mountain snow and ice alter the chemistry of enclosed lakes? The tufa does not answer alone, but it contributes a precise local witness. That witness is valuable because it formed at the interface of groundwater and lake water. Lake sediments can tell you what's settled through the water column. Shorelines can show where water once stood. Tufa adds another perspective. It records where spring discharge met the lake floor chemistry directly. That makes it especially sensitive to both subsurface hydrology and lake conditions. A tower is therefore a kind of double archive. It remembers the hidden movement below and the open water above. If either changed too much, growth changed too. This makes the stone unusually rich for interpretation. Imagine standing before one tower and tracing the evidence from outside in. The outer whitened skin tells of long exposure in desert air. A rough broken edge reveals porous internal structure. Within that structure are cavities where water once moved, perhaps centrally, perhaps along the walls of a vent. A denser band crossing part of the tower suggests a period when deposition became more concentrated or less interrupted. The tower's base sits on sediment now dry, but clearly once part of a submerged spring setting. Its elevation relative to nearby forms hints at the level of the old lake around it. Each observation is small. Together they let you read not only a shape, but a sequence. First, spring discharge through lakebed sediment, then carbonate precipitation in a stable submerged zone, then shifts in flow and texture over time, then falling lake level, then exposure, then weathering and ecological reuse in the modern basin. The climate archive is not hidden behind the scenery. It is the scenery once you know how to look. Dating helps give that reading an actual timeline. Carbonate deposits like tufa can sometimes be constrained by radiometric methods, allowing scientists to estimate when certain phases of growth occurred. Those dates can then be compared with independent records from sediments, glaciers, or other pluvial lakes. If several lines of evidence agree that a basin was fuller during a given cold interval, confidence grows. If one record suggests an earlier or later change than another, the difference becomes a question worth pursuing. Perhaps local groundwater lagged behind surface inflow. Perhaps one shoreline reflects a short-lived stand, while tufa requires longer stability. Other differences may come from the nature of tufa itself, because it does not form in every high lake, only in places where groundwater, chemistry, and time align. That selectivity is part of what makes the towers so valuable. They are not a blanket spread across the whole basin floor. They are a set of chosen points where the hidden plumbing of the valley happened to rise into the lake at the right moments. So when scientists read them, they are really reading a conversation between broad climate and local geology. A colder interval could fill the lake, but if spring discharge weakened in one area, a tower there might stop or never begin. Another nearby vent, fed by a steadier path through the sediments, might continue laying down carbonate quietly for centuries. This means the tufa record is both precise and partial. It shows real events, but not every event. It preserves conditions where stone could grow and lets other conditions pass without leaving the same kind of monument. That incompleteness is not a flaw. It is one more reminder that landscapes keep memory unevenly. Some years leave little behind. Some centuries become a wall of porous carbonate. Some changes are recorded in a shoreline bench cut into sediment. Some are held in a subtle isotopic shift within one pale crust. And some vanish entirely, except for the way they prepared the ground for what came next. If you move slowly among the towers with that in mind, every visible feature seems to carry two weights at once. There is its immediate physical weight, a ledge, a cavity, a buttress, a flaking rim. And there is its evidentiary weight, what that form implies about water depth, spring persistence, lake chemistry, and the timing of exposure. A deep hollow may once have channeled upward flow. A broad base may indicate prolonged accretion near a stable vent. A tower stranded well above the present remnant water may preserve the memory of a much larger lake stand. Even the spacing between towers begins to matter more. If one cluster follows a line, it may suggest a buried fracture zone or a band of permeable sediment where groundwater preferred to rise. If another stands alone, it may mark an isolated vent that remained active despite changing conditions around it. The basin starts to feel less like an open blank and more like a page covered in faint handwriting. You cannot read every letter, but enough remains to follow the sentence. One of the quietest things the Tufa reveals is that climate change in a basin like this is rarely just a matter of more water or less water. The chemistry of that water matters. Its temperature matters, the source of dissolved minerals matters, the duration of a lake stand matters, a brief rise in level may leave a shoreline mark and then fade. A long, stable interval can allow spring discharge to build actual structures. That difference helps explain why the stone feels so patient. It required not only favorable conditions, but persistent ones. And persistence in geology is often more important than intensity. A short, dramatic pulse may stir a basin. A long, calm balance can build a tower. That principle widens the emotional scale again. What first seemed like an isolated shoreline curiosity now becomes evidence for how long a climate state held. Not merely that the valley was wetter, but that it stayed wet enough, cool enough, and chemically suitable enough for carbonate to accrete over many seasons. That is a more intimate kind of climate memory than a broad map can offer. It is climate made local, climate made tactile, climate held in a surface you could almost trace with a fingertip. And yet, for all that can be read from it, Tufa keeps a reserve of mystery. No archive is complete, and porous stone especially invites humility. Later weathering can soften edges. Groundwater can alter inner chemistry. Exposure to air can change outer crusts. A cavity may preserve one process clearly while hiding another. The record is not false. It is simply incomplete in the way all natural records are incomplete. That incompleteness matters because it protects the valley from becoming only a solved problem. Science can explain much here, and beautifully. Still, the towers retain enough ambiguity to remain alive in the mind. One layer can be assigned to stable deposition, but not every day of that stability can be reconstructed. A spring path can be inferred, though not every turn of its underground route recovered. A lake stand can be dated, but the exact appearance of the water on a given cold morning, thousands of years ago, remains beyond reach. This balance between knowledge and silence suits Owens Valley. The basin has a way of making certainty feel gentle. You learn a great deal, but never enough to exhaust the place. That is especially true when the Tufa of Owens Valley is compared with other basin records across the region. Elsewhere in the Great Basin, ancient lakes also left terraces, shorelines, sediments, and carbonate deposits. Each basin responded to the same broad glacial cycles, but each had its own topography, groundwater pathways, and evaporative balance. Some filled more deeply, some dried earlier, some preserved clearer shorelines. Some held thicker sediment records. Owens Valley contributes its own voice to that larger chorus. Its tufa helps connect local hydrology to regional climate rhythms. When viewed together, these basins show that the Pleistocene interior west was not a static, cold landscape. It was dynamic, but in a measured way. Storm tracks shifted. Snowpacks expanded and shrank. Runoff patterns changed. Closed lakes rose and fell. Groundwater systems adjusted. And in certain places, such as this one, carbonate slowly accumulated at the boundary between underground and open water. A continental pattern entered the valley one spring vent at a time. That is a remarkable compression of scale. The same sequence that shaped entire regions can be read in one pale spire at the edge of Owens Lake. It is almost impossible not to pause there. The tower stands only a few feet high, perhaps, or perhaps taller, roughened by wind and dryness. But it links mountain snow, underground circulation, alkaline lake chemistry, and glacial age climate in one object. No wonder it can feel a little unreal in the desert light. It is carrying too much time for its size, and still it does so without any strain. It simply stands. As the day in the valley begins to bend toward evening, the color of the basin changes again, and with that change, the tufa becomes less analytical for a while. The harsh white of midday softens, The pores and hollows show shadow more clearly. The ridges of old deposition gain depth. A tower that looked flat in noon glare now reveals a whole geography of recesses and flanges. This change in light is not just beautiful, it makes the archive easier to feel. The surfaces begin to look once more like the products of water, rather than merely sun-bleached stone. Some contours seem wave-smoothed, though they were built more than carved. Some cavities darken enough to suggest depth beneath a vanished lake surface. The old greenish water returns to the imagination, and with that imagined water comes a renewed sense of what the Tufa has kept. It has kept evidence of submerged springs. It has kept evidence of prolonged lake presence. It has kept the broad outline of climate change. But it has also kept a less measurable thing. It has kept tempo. The speed of its formation is still visible in its texture. Fast geological events often leave sharp scars, tilted layers, or broken ground. Tufa leaves something softer. Knobs build on knobs, bands thicken gradually, openings narrow by accretion rather than force. Even its irregularity is patient. You can see, almost at once, that this was not a hurried landscape. That perception matters because it changes how the whole valley is received. The Sierra to the west may appear sudden in profile. The flats may appear severe in brightness. The dry air may seem to erase softness from the land. Yet the Tufa contradicts any idea of haste. It reminds you that the basin has long been governed by accumulation, retreat, concentration, and exposure, all slow verbs. The mountains fed snowmelt slowly. The lake filled slowly. The chemistry precipitated slowly. The water withdrew slowly. Wind and salt altered the towers slowly. Even now, the present basin continues in the same register. The consequence of reading climate in Tufa is therefore not only scientific enlargement, it is also a shift in emotional pace. You begin to trust slowness more deeply. That trust prepares the valley for evening. By now, the birds at the margins may seem fewer or simply quieter. The shallows reflect more sky. The alkali flats lose some of their glare and become broad, pale fields again. A slight breeze lifts dust in low ribbons. The Tufa towers, which in full sun could look almost stark, begin to glow with a more forgiving light. And because the day is cooling, the basin's surfaces separate into their textures again. Dry crust, damp edge, open water, porous stone, soft sediment, each regains distinction. This is a good time to gather the cause and effect without rushing it. Snow fell and accumulated high in the Sierra during colder intervals. That snow and ice fed streams and groundwater. Owens Valley, being a closed basin, retained water. Lake Owens expanded and remained high enough in some periods to submerge spring zones for long spans. Calcium-rich groundwater rose through the lake bed. Alkaline lake water surrounded it. Where those waters met, calcium carbonate precipitated and coated surfaces around vents. Thin deposits grew thicker. Crust became collar. Collar became mound. Chimney wall. Branching tower. Then climate shifted. Inflow and evaporation moved into a different balance. The lake receded. The towers emerged. Submerged chemistry ceased to operate in the same way on their exposed surfaces. Sun, wind, salt, and dust took over. The towers whitened, weathered, and endured. Around them, the modern basin developed its quieter life of microbial films, seasonal pools, sparse plants, and birds at the edges. And now, in evening light, all of those phases seem present at once. That simultaneity is one of the deepest comforts of the place. The basin is not only past or only present, it is layered. Ancient lake, buried spring, exposed mineral, living shore, none of them has disappeared entirely. Some are visible, some are inferred, some are active now in reduced form, all remain part of the same arrangement. Perhaps that is why the Tufa does not feel like a relic in the ordinary sense. A relic often seems cut off from the process that made it. These towers do not. Groundwater still moves in the valley. Salts still concentrate in shallow water. Minerals still precipitate in smaller, different ways. Climate still governs inflow and evaporation. Wind still reshapes the basin's surface. The old conditions are gone in their full combination, but the ingredients are still present. The conversation continues, even if its grammar has changed. That unfinished quality is important. It keeps the landscape open. There is no final version of Owens Lake, no completed arrangement of shore, tower, salt, and sky. Even the exposed Tufa, which seems so still, remains within change. A little edge will break in time. A little sediment will gather at a base. A cavity will catch dust. A nearby wet margin will advance one season and retreat the next. The basin remains in motion, just motion at the scale of patience. In the cooling air, the Sierra Nevada begins to hold the last brightness, while the flats below dim first. That vertical difference in light echoes the whole history of the valley. The mountains continue to receive and release the water story before the basin shows its consequences. Snow up high, runoff later below. Cloud shadow on granite, then changing chemistry in closed water. Alpenglow on the crest, then dusk among the towers. It is the same relationship across different timescales. The Tufa keeps pointing back to it. Every porous wall is a reminder that the valley's quietest forms were built from a connection between heights and hollows. That connection becomes almost tender at day's end. You can stand among the pale structures and feel how much of this story depended on water being allowed to travel and linger. From cloud to snow, from snow to stream, from stream to lake. From subsurface flow to spring vent, from dissolved ions to solid carbonate, from submerged architecture to dry archive. And still the process does not settle into a moral or a warning. It remains what it is, an arrangement of matter under changing conditions. The peace of the basin comes partly from that indifference. Nothing here formed for an audience, nothing here was trying to become picturesque. The towers were simply the outcome of chemistry meeting duration in the right place. The fact that they are beautiful is secondary, though very real. In dusk, that beauty becomes quieter still. The whitest surfaces turn pale grey. The deepest cavities begin to merge with shadow. The open water, where it remains, reflects a dimmer sky and loses its hard edges. Farther out on the flats, brightness seems to lift off the ground and leave behind a soft, matte stillness. This is when the basin feels most spacious. Details remain, but they stop asking to be named. The towers become silhouettes of process rather than specimens. The valley becomes a single field of relation: mountain, basin, remnant water, salt, stone, air. Yet even here, where the scene could drift wholly into atmosphere, the Tufa keeps a subtle tension alive. It has told much. It still withholds much. You know how it formed in broad terms. You know the ingredients. You know the sequence. But you do not know every pulse of the spring that built one inner chamber. You do not know every season of the lake as it lapped those growing rims. You do not know every slight shift in chemistry that changed one crust from dense to porous. Mystery remains in the details, not because the process is unknowable, but because time is too large to recover completely. That is not frustrating here. It feels appropriate. The stone has preserved enough. Enough to show connection, enough to show duration, enough to show exposure, enough to place the valley inside larger climatic rhythms, and enough silence left over that the place can still breathe. As evening settles further, the modern ecosystem withdraws into subtler signs. Small movements near the shore become harder to pick out. A bird call, if one comes, seems to travel farther in the cooling air. The shallow margins lose color and become tone. Only the tufa, with its pale surfaces, continues to hold a little of the remaining light. This makes the towers feel almost self-luminous for a short while. Not bright, just persistent. They gather what the day has left and release it slowly. That visual effect deepens the sense that they are keeping something. Not a secret in the dramatic sense, more like a reserve of time. The texture of submerged springs, the level of vanished water. the chemistry of an inland lake that no longer surrounds them. The pacing of climate shifts far longer than a human season, the way a closed basin can turn invisible processes into visible form. All of that remains in them, though no single glance could take it in. The valley at dusk invites a slower way of knowing. You stop trying to solve the towers all at once. You let each one hold only a portion of the answer. This tower perhaps grew around a stable vent. That one perhaps incorporated vegetation or branched flow. This cluster may mark a line of groundwater rise. Those lower mounds may preserve a later, lower phase of lake presence. The archive becomes distributed, like stars emerging one by one rather than all at once. And while that distributed understanding gathers, another thought comes quietly forward. The tufa is not permanent in the deepest geological sense. It feels durable to you because it bridges vast spans of time. Still, carbonate can erode. Sediments can bury. Salt and wind can alter surfaces beyond recognition. Future changes in water management, weather, dust, and climate will continue shaping what remains visible. Some towers will crumble. Some will stand longer than others. Some textures now legible may blur. Others may be newly exposed as surrounding sediment shifts. So, even the archive is active. It is not frozen outside time. It is simply moving on a slower schedule than the eye usually expects. That recognition makes the place more moving, not less. To know that the towers endure only provisionally is to understand them more truthfully. Their power lies not in absolute permanence, but in long temporary survival. They have lasted long enough to carry one world into another. That is already extraordinary. And the basin, by holding them in such open light, lets you feel the full stretch of that carrying. The last warmth drains from the flats. The mountain crest cools to rose, then fades. The remnant water darkens. The tufa towers remain pale a little longer, then begin to fold into the surrounding dimness. At this hour, the valley's silence does not feel empty. It feels assembled. Water made this silence. So did evaporation. So did buried springs. So did seasons of snow in distant cold ages. So did the exposure that brought underwater stone into desert air. Everything has contributed. Nothing needed to hurry. And because nothing hurried, the resulting quiet feels complete enough to rest in. Still, the story inside the stone is not exhausted. If anything, evening makes the inward turn stronger. When detail in the surrounding landscape softens, the mind returns to the porous walls themselves, to their bands, cavities, crusts, and branching forms, to the way each tower is both shape and evidence, to the possibility of reading old climates from textures that at first glance seem merely strange. That return inward is natural now. The day's long view has prepared it. The ecosystem has shown how present life gathers around ancient mineral relief. The climate story has widened from local spring vents to regional glacial rhythms. What remains is to linger with the record itself a little longer, while dusk deepens, to stay close to the stone and notice what it still refuses to say plainly. A porous wall can preserve old water paths, but it can also erase them by collapsing slightly after exposure. A dense crust may indicate one stable interval, yet hide the finer alternations within it. A cavity may look simple in shadow, though it formed through several stages of accretion and abandonment. The archive is legible but not transparent. That is why careful reading matters. Scientists do not approach a tufa tower as a solved emblem. They approach it as a layered object, one in which visible structure, internal texture, chemical composition, and landscape position all have to be considered together. Take the position of a tower first. Its elevation relative to other deposits can suggest when it formed in relation to former lake levels. If it stands far from the modern remnant water, that distance itself becomes part of the evidence. The tower is not merely old. It belongs to a shoreline condition very different from the present one. Now consider its shape. A narrow chimney may imply focused upward discharge. A broader mound may suggest spreading flow or repeated incrustation around a wider spring area. Add texture. Knobby surfaces can reflect uneven accretion. Smoother bands may mark intervals of more uniform deposition. Then add the chemistry preserved in its carbonate. Only after those pieces are placed side by side does a fuller interpretation emerge. The process is patient, and it mirrors the patience of the stone. You do not force a tower to tell one story. You listen for the several stories it can tell, and for the ways those stories overlap. That method has allowed Owens Valley Tufa to contribute to a larger paleoclimate picture in meaningful ways. A tower can be sampled and dated. Its isotopic composition can be compared with known patterns from lake sediments or shoreline evidence. If the ages cluster during certain cold intervals, that suggests those were times when the lake and spring conditions favored substantial tufa growth. If isotopic values point towards specific balances of inflow and evaporation, they help refine what kind of lake occupied the basin then. If the towers occur at elevations corresponding to former shorelines, the geometry of the lake can be reconstructed more confidently. In this way, tufa acts less like an isolated curiosity and more like a hinge between different kinds of data. And once you begin to see the towers that way, the valley becomes easier to read across scales. A pale wall a few feet high can now stand for a whole interval of colder weather. A rough cavity can hint at water rising from below with enough steadiness to keep a vent open. A line of deposits across the flats can imply a shoreline that held in place long enough to matter. The evidence is local, but the implications widen outward almost at once. That widening is one of the gentlest surprises in Owens Valley. You start with a stone shape beside shallow water. You end up thinking about storm paths over the Sierra, long winters, delayed melt, and the balance between inflow and evaporation in a closed basin. The towers do not force that expansion. They simply allow it. Their porous walls keep enough of the old lake's story that the surrounding landscape begins to fall into relation around them. The same mountain front that now glows in evening light once fed the basin in a different rhythm. Snowfields lingered longer. Runoff continued farther into the warm season. Groundwater systems had time to respond. Fresh water moved not only across the surface in streams, but also downward into sediments and rock, then laterally, then back upward through the lake bed. By the time that water reappeared at a spring vent, it was carrying a different chemical history than the water above it. That difference was the beginning of Tufa. So the towers are never only about the lake itself. They are also about movement through the valley's hidden plumbing. The surface lake was visible, the spring pathways were not. Yet the two had to meet in exactly the right way. That requirement gives the stone a certain selectiveness. Not every place along the old shore could produce the same forms. Only the places where groundwater rose and where lake chemistry remained suitable could assemble these pale structures. That means absence is informative too. Where there is no tufa, perhaps the spring discharge was weak. Perhaps the sediment was not fractured in the right way. Perhaps the lake bed there did not host the same chemistry for long enough. The basin is full of conditions, but the towers mark the places where several conditions overlapped. That overlap is the true rarity, and because it is rare, the record is especially precious. A shoreline alone can tell you where water stood. A sediment layer can tell you what's settled out. A tower can tell you where the lake and the subsurface touched in a productive way. It narrows broad climate into a precise meeting place. That precision matters when the goal is not only to imagine the past, but to reconstruct it carefully. For example, if a certain group of tufa deposits formed during one lake high stand and another group formed at a slightly lower level, the basin may preserve a sequence rather than a single episode. One stable shoreline might have lasted long enough to build substantial towers. Later, as the lake fell, a lower stand might have allowed new growth elsewhere, under altered chemical conditions. The result is not one simple rising and one simple retreat. It can be a stepped history with pauses, adjustments, and localized continuations. That possibility makes every cluster of tufa more interesting. A field of broad mounds may belong to one hydrologic phase. A lower set of smaller incrustations may belong to another. A tower with multiple textural zones may carry both within itself. In this way, the stone does not merely say that the lake changed, it suggests how it changed. Gradually, unevenly, and through intervals of temporary balance. That is often how quiet landscapes preserve their most useful truths, not in extremes. In pauses, a pause in falling water level, a pause in changing chemistry, a pause long enough for mineral to accumulate rather than dissolve or dry. Tufa is the material result of those pauses, and pauses are exactly what make a climate history feel real. If conditions change too quickly all the time, the basin would leave a more chaotic record. Because there were periods of relative steadiness, the archive can hold shape. It is worth lingering with that idea because it helps explain the emotional quality of the place as much as the scientific one. Owens Valley feels calm partly because the record itself was built by calm intervals. Even when the broader climate of the Pleistocene shifted, it still did so over spans long enough for lakes to expand, endure, and withdraw in stages. The basin had time to respond. The springs had time to find their roots, the carbonate had time to settle. And now the eye has time to follow what remains. If you imagine one particular tower again, perhaps standing a little apart from the others, its shape begins to gather multiple meanings. Its base rests on sediment that was once lake floor. Its walls were built where fresh and alkaline waters mixed. Its cavities suggest old internal pathways. Its weathered surface reflects long exposure. Its height above the present margin tells you that the basin was once fuller. Its persistence into the present allows birds, dust, salts, and shadows to use it in new ways. One object then carries hydrology, chemistry, climate, ecology, and time. No wonder the towers seem quieter the longer you look at them. They are doing so much without any display. The same quiet complexity appears when scientists compare Owens Valley with other paleo lake systems in the interior west. Some basins preserve broad wave-cut terraces more clearly than spring-built carbonates. Some hold thicker lake sediments. Some contain other forms of shoreline evidence. Owens contributes something especially intimate. Its tufa preserves the local expression of a large climate story. A continental-scale cooling could alter storm tracks and snow accumulation. That snow could feed streams and groundwater. That groundwater could rise beneath a closed basin lake. And right there, at one vent in one lake bed, a thin band of calcium carbonate could begin to form. That chain is astonishingly direct. It reminds you that global and regional changes only become real landscapes by passing through specific places. No climate exists in the abstract for long. Sooner or later, it becomes water level, dissolved mineral load, spring discharge, and stone. The valley makes that translation visible. And still, the towers are careful witnesses. They do not preserve every chapter equally. A long, stable interval may be represented strongly. A brief oscillation may be faint. An episode of later alteration may overprint an older texture. Some towers may have been partly buried, then re-exposed. Others may have lost their more delicate upper forms. So the archive has to be handled with patience. That patience is not a burden here. It feels appropriate to the subject. You read Tufa the way it formed, layer by layer, with no need to rush. The idea of incompleteness grows gentler the more you stay with it. At first, incompleteness can sound like a limit, but in geology, partial records are often the most honest ones. No landscape keeps everything. What matters is whether enough of the pattern remains to reveal the process. At Owens Lake, enough remains. Enough to show that the basin once held much more water. Enough to show that spring-fed carbonate growth took place underwater. Enough to link those deposits to changing climate across the Great Basin. Enough to let the present landscape inherit the structure of a vanished one. What remains unknown does not erase that. It simply leaves the towers with some privacy. That privacy is part of their beauty. Even under close study, they do not surrender every detail. A vent may be recognized, but not every pulse that passed through it. A layering pattern may be measured, but not every season of water temperature that helped shape it. An isotopic trend may reveal broad hydrologic change, but not the exact color of the old lake on a particular afternoon. There is room, still, for imagination disciplined by evidence. That combination suits evening. The basin is dimming now, and dimness naturally softens the urge to resolve every question. The light that remains finds the edges of the towers and leaves their inner cavities in shadow. Some shapes stand out more clearly than before, others merge into the flats. This shifting visibility mirrors the archive itself. Some phases of the past are plain, others recede. The more you look, the more you understand that stone can preserve history without preserving it evenly. This unevenness is not unique to Tufa. It is part of the wider history of Great Basin lakes. Some old shorelines remain sharp, others have been softened by later erosion, burial, or human alteration. Some sediment cores preserve fine annual layers, others are interrupted. Some carbonate deposits hold strong chemical signals, others have been altered enough to require caution. Owens Valley fits within that larger pattern of selective memory. It offers one especially graceful form of retention, but not a perfect one. That is why comparison across records matters so much. A shoreline bench can support what a carbonate age suggests. A sediment core can confirm whether a lake was deep or shallow during the same interval. Regional glacier records can help estimate the colder conditions that sustained runoff. Each line of evidence leans gently on the others, and the tufa, because it forms at such a precise interface, often helps tie them together. It becomes a bridge between visible landform and invisible chemistry. That bridging role has another consequence. It changes how you stand in the landscape. You are no longer only beside the remains of an old lake. You are beside a place where the surface world and the subsurface world once met continuously. That meeting has a different feeling than ordinary shorelines do. A shoreline usually suggests horizontal movement, waves, inflow, retreat. Tufa adds a vertical element. Water was rising from below even as the lake spread above. The basin was not simply receiving water from the mountains. It was circulating it through hidden paths and returning it upward. That makes Owens Valley feel more layered, more dimensional. The old lake was a body on the surface, the springs were a body beneath it. The towers are where the two touched. That touch left a mineral architecture so distinctive that even after the lake withdrew, the contact remains visible. It is almost like finding the seam of a vanished conversation. One voice came from the groundwater, one from the basin lake. The words were calcium and carbonate. The sentence was stone. By now, night is approaching more clearly, and with it the surrounding details begin to loosen. The microbial colors at the edge of damp flats fade first, then the subtle changes in salt crust become harder to distinguish. Water remains visible because it holds the sky a little longer. The towers stand between these two forms of fading, brighter than the flats, darker than the water. They occupy the middle tone of the evening. That visual position feels fitting. All along, the tufa has been a middle thing. Not fully lake, not fully land, not fully past, not fully present, not fully scientific specimen, not fully sculptural mystery. A threshold object in a threshold basin. And thresholds are often where memory persists best. Perhaps that is because change leaves its marks most clearly at boundaries. Where one kind of water met another, tufa formed. Where submerged growth met air, weathering began. Where ancient mineral structure meets modern salt flats, ecology gathers in small ways. Where local geology meets regional climate, paleohydrology can be read. The whole valley can be understood through such boundaries. Mountain and basin, snow and evaporation, groundwater and surface water, stone and dust. Then and now, what the tufa keeps, more than any single fact, is the continuity between those pairs. It shows that the boundaries are real, but not absolute. Mountain snow became lake water. Lake water interacted with groundwater. Groundwater became carbonate. Carbonate became desert landmark. landmark became microhabitat. At no stage was the process fully isolated from what came before or after. That continuity is one reason the basin resists feeling ruined, even though so much water is gone from its older form. A ruin suggests a completed break. The tufa suggests transformation instead. The original underwater setting has passed, yet the stone remains active as evidence, as texture, as shelter, as shape, as a point around which interpretation still gathers. The old lake is absent, but not erased. It has become legible in another medium. This is a subtler kind of survival than water alone could have offered. A lake can disappear from sight. A spring can shift underground. A climate state can end. A carbonate tower can keep all three in relation, and that relation grows stronger as the last light drains away. In near darkness, the towers lose some detail but keep their outline. That outline is enough. You can no longer trace every pore. You can no longer distinguish a fine band from a rough one unless you stand very near. But the broad truth remains visible. There was growth here. There was water here. There was stillness here for a long time. The basin does not need more than that at this hour. Its full complexity can return in daylight. For now, shape is enough to hold memory. Still, even shape can be misleading if taken alone. A tower silhouette may suggest a single period of growth when in fact it preserves several. A broad mound may look simple at dusk and reveal dozens of textural shifts by morning. A low wall may seem like a broken remnant, though it could represent a distinct kind of spring discharge. This reminder matters because it keeps the narrative open. The towers never become mere symbols. They remain material things with complicated histories. That materiality is part of their sleep-like calm. They are not abstractions floating free of place. They are porous, brittle in spots, dense in others, rooted in sediment, dusted with salts, touched by temperature and wind. The more carefully you imagine them, the more soothing they become. Not because they are soft, exactly, but because they are specific. Specific things steady the mind. A cavity once held rising water. A rim once grew underwater in dim green light. A lower band dried sooner than the one beneath it as the lake receded. A shaded side now cools earlier than a sunlit side in the evening air. Detail gathers the world gently. And Owens Valley has always asked for that kind of gathering. It is easy to look across the basin and think first of emptiness. The flats are wide, the vegetation is sparse, the distances are open. But as the story of Tufa unfolds, emptiness gives way to structure. The basin is organized by water, even in reduced form. It is organized by chemistry, even when chemistry is invisible. It is organized by old shorelines, by spring pathways, by seasonal wetting, by evaporative crusts, by slight rises and hollows in the sediment. The towers are the most visible punctuation in that order. They announce that the apparent simplicity of the valley is really the surface of layered processes. That realization can be carried back inward one more time. A tower does not only reflect one vanished lake stand, it also belongs to the deeper logic of closed basins everywhere. Where water flows in but does not flow out, concentration follows. Dissolved minerals accumulate over time. Chemical thresholds become important. Shorelines migrate with climate shifts. Groundwater and lake water can develop distinct compositions. In some fortunate places, their meeting precipitates stone. Owens Valley is one of those places. Its tufa is therefore local in expression, but universal in principle. It shows what happens when a basin keeps what enters it, and time is allowed to work. That universality is peaceful. It means the valley is not strange in some unreachable way. It is simply a clear example of patient natural law. Given topography, water, chemistry, and time, such forms become possible. What feels miraculous at first gradually feels inevitable, and when something feels inevitable in nature, fear tends to fall away. You do not need to be startled by the towers. You only need to understand the terms that made them. Those terms are gentle ones. Snowfall, runoff, groundwater, alkalinity, calcium, evaporation, exposure, weathering. Nothing dramatic in itself. Yet together, over long spans, they make a landscape memorable enough to seem almost deliberate. That is one of geology's quietest gifts. It reveals that wonder can arise from ordinary processes held steady for extraordinary lengths of time. Perhaps that is why the basin at nightfall feels more intimate than grand. The Sierra still looms in the distance, and the flats still stretch outward, but the towers keep drawing your attention to the hand scale of deep time, a ledge you could touch, a cavity no bigger than a cup, a crust thinner than a fingernail, repeated until it becomes a wall. The vast and the small keep meeting here. Climate enters stone through tiny precipitations. A whole lake history becomes visible in a rough white mound. A regional glacial rhythm rests in one porous spire. The compression is calming. It means you do not have to hold all of time at once. The tower holds some of it for you. The night air grows cooler. The open water, where it remains, darkens towards slate. The alkali flats become less reflective and more velvety in tone. The towers, still faintly pale, keep their form a little longer than the basin floor around them. This persistence in low light is not only visual, it feels thematic too. The Tufa has persisted through shifts of water level, climate, and exposure. Now it persists through the fading of the day. Its outlines continue while other details recede. That is what memory often does. It keeps the structure after the finer textures have gone dim, and so the basin settles into a deeper quiet, but not an empty one. The quiet is full of retained process. Underground water once rose here. Alkaline lake water once held it. Carbonate once settled out, molecule by molecule. Then the lake withdrew. Then air and salt and dust took over. Then small present-day lives gathered around the roughness that remained. Each stage has been slow enough to leave some trace in the next. That continuity is what the Tufa keeps most faithfully. Not exact scenes, not complete dates, not every vanished shoreline. It keeps continuity. It keeps the fact that this valley has long been shaped by relationships rather than isolated events. The final light from the Sierra fades further, and now the towers stand in a kind of neutral dusk. At this point, the urge to measure them gives way to the urge simply to remain near them. This, too, is part of understanding. Not every truth in a landscape arrives by analysis. Some arrive by letting the pace of the place set your own. Owens Valley moves by accumulation and retreat, by concentration and dispersal, by slight changes repeated many times. To sit with the Tufa at the edge of evening is to accept that tempo, and once you accept it, more of the basin opens without effort. The old lake stops feeling remote. The springs stop feeling hypothetical. The climate shifts stop feeling abstract. Everything becomes specific, but softly specific. Water deepened here. Water mixed here. Stone grew here. The shore moved away from here. Dust settled here. Shade gathered here. A bird fed here. A microbial film darkened here. One place many times. The story remains unfinished because the basin remains unfinished. Future winters will still gather snow in the Sierra, though not in the same measure every year. Future runoff will still find the valley floor. Groundwater will continue its slower hidden movements. Salt will continue to concentrate where water lingers and then departs. Wind will continue to sort fine sediment around the bases of towers. Small breaks in a fragile rim will continue. New exposures may appear as surrounding sediments shift. Even the scientific story is unfinished. A better sample, a new date, a closer comparison with another basin record. Each could refine what is already known. That open-endedness belongs to the towers as much as their age does. They are old but not closed. They are studied but not exhausted. They are still giving information because the valley is still in process. And this is where the feeling of dusk deepens into something almost tender. The Tufa does not need to conclude anything. It only needs to continue standing long enough for another morning, another season, another reading. Its value is not that it has the last word on Owens Valley. Its value is that it keeps the conversation possible. Stone can do that sometimes. If you stay a little longer in that dimness, another quality of the tufa begins to matter. It is not only that the stone preserves evidence, it also preserves gaps. Between one band and the next, there may have been years when growth slowed. Between one shoreline position and another, there may have been long pauses in the lake's retreat. Inside a hollow tube, the water path may have shifted more than once before the opening was left dry. Those gaps are part of the record too. They remind you that deep time is not smooth. It moves in stretches of steadiness, then adjustment, then steadiness again. That pattern is often clearer in Tufa than in a distant mountain face. A mountain can hold ages in silence, but the story is spread too widely to read at a glance. A Tufa tower compresses a lake's hesitation into a wall of porous carbonate. It lets you see where the basin lingered. And lingering is important here. The tallest dry towers only exist because the lake remained around them long enough to build them substantially before it moved away. A brief lake would have left much less. A shallow, unstable margin would not have produced the same thick collars, broad mounds, and vented chimneys. So every substantial tower quietly argues for duration. Not endless duration, but enough. Enough cold, enough snowmelt, enough inflow, enough submerged chemistry, enough patience. That is the next consequence of reading the basin carefully. The Tufa does not merely tell you the valley was different once, it tells you the difference lasted. And from there, the climate story becomes more specific. In closed basins like this, one, lake level depends on balance. Water comes in through runoff, stream flow, and groundwater. Water leaves mostly through evaporation. If cooler conditions reduce evaporation, a lake can persist with less inflow than it would need in warmer times. If snowpack increases in the mountains, more meltwater reaches the basin. If both happen together, lake stands can become much more stable. That stability is the quiet requirement beneath the towers. The carbonate did not need dramatic floods. It needed a lake that kept returning, or simply stayed. It needed the old shore to hold still enough that a spring vent was not repeatedly stranded. And so the tufa becomes evidence for climate not as a single moment, but as a sustained state. That distinction matters. A storm can fill a wash. A decade of colder balance can help maintain a pluvial lake. 100 years of suitable mixing can leave a visible mineral body. The towers belong to the longer category. They were assembled by conditions that endured beyond weather. That is why scientists compare them so carefully with other records from the region. A shoreline bench alone might mark one high stand. A sediment layer might suggest greater water depth. But when dated tufa agrees with those signs, the confidence deepens. Several separate forms of evidence begin to point toward the same interval of fuller water. And if those intervals line up with glacial signals in nearby mountains, the whole picture steadies. Snow and cold at high elevation, sustained inflow to the basin, longer-lived lake stands, submerged spring discharge, carbonate growth at the lake floor, the chain closes. Yet it never becomes mechanical, because local geology always shapes the final expression. One spring zone may have had more calcium-rich discharge than another. One patch of sediment may have allowed upwelling more easily. One vent may have remained open, while another clogged with mineral or shifted sideways into a new path. So even under the same broad climate, the towers keep their individuality. That individuality is not noise in the record. It is part of the record. It shows that climate acts through place. General conditions set the stage. Local structure decides where the stone actually gathers. This makes the old lake feel less like an abstract watersheet and more like a living arrangement of differences. Some parts were deeper, some shallower, some spring-fed, some quiet, some more alkaline than others at certain times, some favorable to thick tufa growth, some not. If you imagine the whole basin during one of its fuller phases, it becomes textured. Not only open water under a cold sky, but a bottom threaded with hidden discharge points. At each of those points, the chemistry was slightly special. Not dramatic to the eye, perhaps, but enough to turn dissolved minerals into solid architecture. In that sense, the Tufa Towers are concentrated places. They are where the basin's larger climate history sharpened into local mineral fact. A broad atmospheric pattern cannot be seen directly in Owens Valley now, but one old vent mouth can still show where that pattern mattered. That is a profound compression. And it also explains why the towers can seem so intimate in evening light. They are personal in scale, though they belong to systems much larger than themselves. You can look into one cavity and think about groundwater. You can step back and think about the Great Basin. You can turn farther and think about glacial climate over western North America. The transitions between those scales are unusually smooth here. Nothing feels forced. Everything leads into everything else. The stone makes the movement easy. If you were to follow one line of evidence more closely, the shoreline position would be one of the clearest. Tufa occurs at elevations that correspond to old water levels. That means the towers are not only chemical traces, they are also level markers. Where they stand, the lake once stood around them. If a particular group lies higher on the basin margin, it implies a fuller lake than deposits lower down. If those groups differ in age, then the basin preserves a sequence of changing stands. That sequence may not be perfectly continuous, but it is often enough to show direction. Water rose, stabilized, shifted, fell, paused, fell again. The consequence is subtle, but important. Lake withdrawal was not simply one long, smooth slope downward. It may have included temporary still points, moments when the edge held, moments when chemistry remained favorable long enough for new crust to build, moments when a tower that had been submerged to one height found growth concentrated lower down as the water shallowed. Those pauses are what allow the basin to keep such readable memory. Without them, the record would blur. And this returns you to the old idea that calm intervals preserve more than rapid ones do. In Owens Valley, the periods of relative balance mattered immensely. They are the reason ancient process can still be seen with such clarity. A lake in constant upheaval would leave fewer delicate structures. A lake that quieted for stretches could host slow mineral assembly. So the towers are not only monuments to change, they are monuments to temporary stability within change. That may be one of the most restful truths the valley offers. Even large systems do not move in uninterrupted restlessness. They settle, they hold, they build. Then they move again. The same logic appears in the stone's textures. A wall with coarse, knobby surfaces may indicate irregular accretion as flow conditions shifted slightly. A smoother, denser zone may suggest a calmer interval when deposition became more even. A large internal cavity may mean one upward path remained open for a long while before mineral narrowed it or the spring changed route. Every visible feature is a physical expression of how stillness and variation shared the same place. You can almost hear the old pacing in that. Not in sound, exactly, but in form. A little mineral settles, then a little more. The vent stays open, then narrows. The lake remains high, then lowers a little. A lower crust begins. The upper wall dries. Wind arrives centuries later. Dust settles. The sequence continues quietly from one environment into another. This continuity is what makes the towers feel less like ruins than transitions made visible. A ruined building implies interruption by force, or at least abandonment of purpose. Tufa has no purpose to abandon. It simply records changing conditions honestly. When submerged, it grew. When exposed, it weathered. When stranded in the modern basin, it became part of a new ecological texture. That is not failure. It is continuity under altered terms. And there is another result of this continuity. The more carefully the tufa is studied, the more Owens Valley becomes connected to neighboring basins and mountain records. A dated carbonate layer here can be compared with a shoreline there. An isotopic pattern here can be set beside a lake sediment core elsewhere. A pulse of glacial melt inferred from one place can be tested against fuller lake conditions in another. These comparisons matter because no single archive carries every answer. A basin may preserve water depth well, but not local spring chemistry. A glacier may preserve cold intervals well, but not lake alkalinity. Tufa contributes its own distinct voice. It helps show when groundwater and lake water were in the right relation for mineral growth. That makes it especially useful in reconstructing hydrologic nuance. Not only whether the basin held water, but how that water interacted with the subsurface. That nuance is easy to miss if you only look at the towers as shapes. But once it comes into view, the entire landscape gains dimension. Owens Valley is no longer just a place where a large lake once sat. It is a place where water moved through several reservoirs at once. Snow stored in the Sierra, runoff crossing the surface, groundwater traveling below, lake water concentrating in the closed basin, evaporative loss to dry air. Each reservoir had its own rhythm. Tufa formed where two of them touched directly. That is why the towers are such elegant witnesses. They stand at a hydrologic intersection, and because they stand there, they can reveal changes in more than one system at once. A shift in groundwater discharge could alter growth. A shift in lake chemistry could alter growth. A lowering water line could alter growth. A combination of all three could halt it. When you look at a tower, then you are looking at the result of several balances holding together for a while. That holding together is never permanent. But it lasted long enough to become stone. It is worth noticing how modest the material itself remains. Tufa is not a polished crystal. It is not dense marble. It is pale, porous, somewhat fragile, full of spaces. That fragility actually helps it speak. Because the water pathways are easier to imagine in such open texture. The stone looks like what it came from. It has the softness of gradual precipitation still visible in its body. A denser rock might hide its own making more completely. Tufa does not. Its architecture announces accumulation. Its cavities announce flow. Its irregularities announce changing conditions. That openness makes it a particularly generous archive. And yet, its very porosity also means it can be altered after formation. Later moisture can move through it. Salt can crystallize in its pores. Surface layers can powder or flake. That is why interpretation always requires caution. What you see today is formation plus modification. The good news is that this layered history can often be separated, at least broadly. A whitened outer rind may belong to long desert exposure. A denser inner band may belong to original subaqueous growth. A broken lip may be weathering. A persistent vent tube may be original structure. The stone asks to be read in stages, and reading in stages changes your relationship with time. You stop asking for one answer, you begin asking which phase a feature belongs to. Underwater growth, retreating lake, exposure, weathering, modern ecological use. Each phase adds, removes, or clarifies something. A tower's present appearance is the sum of those additions and losses. That is true of the basin itself. Its current openness is not a blank condition. It is the result of a fuller hydrologic past, a later reduction in water, ongoing evaporation, salt accumulation, wind movement, and the persistence of old shoreline features. Everything visible now is layered. The tufa simply makes the layering easier to see. Perhaps that is why it keeps drawing your attention back, even as darkness spreads. It is one of the few forms in the basin that clearly belongs to several times at once. The flats belong mostly to the present surface, though they remember older lakes beneath. The Sierra belongs to very long geologic time, though it influences each winter's snow. The remnant water belongs to current conditions, though it echoes a much larger former lake. Tufa sits in the middle and binds those scales together. It is old enough to remember the fuller basin, present enough to stand in evening air, specific enough to be sampled, beautiful enough to be simply watched. That combination is rare, and it also helps explain why the towers remain partly unknowable. Not because the science is weak, but because the archive is rich. Every answer seems to open another question. If one tower formed during a certain high stand, how long did that stand remain stable at this exact spring zone? If a cavity suggests vegetation once coated by carbonate, what kind of near-vent habitat existed in that water? If isotopic values shift up a wall, did lake chemistry change steadily or in pulses? If a line of towers follows one buried path, how many neighboring vents failed to leave any durable structure at all? The basin keeps inviting finer resolution, and that invitation is peaceful rather than urgent. No one question has to be settled immediately. The stone has already waited a very long time. It can wait while understanding deepens. That patience belongs not only to the Tufa, but to the valley's atmosphere as a whole. As the last brightness thins out, the old relationship between the Sierra and the basin grows more abstract. You cannot see the snowfields now, but you know they matter. You cannot see groundwater moving below the flats, but you know it once mattered decisively at these points. You cannot see the old lake surrounding the towers, but its level is still implied by where they stand. Owens Valley becomes a place of inferred presences, not imagined in a fanciful way, inferred from evidence gently. That is one of the quiet pleasures of geology. A dry tower can imply a submerged past without any need for spectacle. A pale wall in low light can carry the outline of vanished water, and because the evidence remains in place, imagination never drifts far from ground. The basin keeps you honest. This is where the stone matters more than the story told about it. The story can become lyrical, as evening invites, but the stone remains factual. Calcium carbonate precipitated here, springs rose here, the lake withdrew from here. Exposure altered this surface. Shallow habitat later gathered nearby. No matter how softly the valley is described, those relations stay firm. That firmness gives the place its calm authority. It does not need embellishment. Its wonder comes from being exact, and exactness in a quiet landscape can feel deeply restful. A tower stands where conditions once aligned. It does not pretend to be anything else. Perhaps the most intimate knowledge that Tufa offers is this: water leaves shapes behind, but only when certain thresholds are crossed. Not every shoreline becomes stone. Not every spring mouth becomes a chimney. Not every lake fluctuation becomes a visible archive. At Owens Lake, those thresholds were crossed repeatedly enough to matter. That means the basin is not only a place where water was present, it is a place where water became legible. The tufa is the legibility. That has consequences for the future reading of the valley as well. As conditions continue to shift over coming years and centuries, some parts of the old record may sharpen while others fade. A bit more sediment may bury one base and reveal another. Salt crusts may emphasize relief in one season and soften it in the next. Weathering may remove a thin outer rind and expose older texture beneath. Scientific methods may improve, allowing finer dating or more subtle chemical interpretation. The conversation between stone and observer remains unfinished because both sides continue changing. That unfinished state is not uncertainty in the troubling sense. It is openness. There is more to learn because the valley still contains more than one timescale. Present weather acts on ancient form. Ancient form still structures present perception. Research adds detail. The stone keeps some reserve. And so the Tufa stands not as a closed chapter, but as a pause in a very long sentence. A pause made visible. A pause you can walk among. A pause where old lake water still seems to cling in the mind, even when the air is dry and cooling. If you picture the basin before dawn tomorrow, the towers will still be there, pale before the flats brighten. Their outlines will once again gather the first light. Their cavities will hold night shade a little longer. Their positions will once again mark water that no longer covers them. Nothing about them will be finished then either. They will continue slowly weathering. They will continue quietly recording. They will continue offering the same layered invitation. Look at the shape, then ask about the water. Ask about the chemistry. Ask about the spring. Ask about the lake level. Ask about the climate that held long enough to build this much stone. And beneath all those questions, another one remains, softer than the rest. What does a landscape keep when almost everything that formed it has changed state? Owens Valley answers with pale carbonate, porous and patient. It keeps relation, it keeps sequence, it keeps the meeting of below and above. It keeps enough of the vanished lake to make the modern basin feel inhabited by deep time. And as you stay with that thought, the shoreline seems to widen inward rather than outward. The Tufa no longer marks only where water once stood. It marks where process can still be followed. From mountain snow to basin water, from hidden spring to mineral wall, from lake chemistry to exposed desert form, from exposed form to microhabitat and climate record. Nothing stands alone for long here. That may be the most enduring lesson in the stone. Even after submergence ends, connection remains. The tower holds to the sediment. The sediment holds old lake memory. The basin still receives light, dust, salts, and occasional water. The mountains still govern inflow from far above. The old and the present keep touching at the shoreline. And below that shoreline, even now, the valley still has its hidden roots. Groundwater does not stop being part of the story simply because the ancient lake is gone. It continues moving through sediments and rock, slowly, invisibly, following gradients set by topography and recharge. Some of those paths are ancient in their own way. Some may shift subtly over time. All of them remind you that the surface has never been the whole basin. The Tufa proved that once by rising where no visible stream entered. It may still prove it now, if you know how to look for slight dampness, altered crust, or the arrangement of remnant wet patches along the flats. Those hints are smaller than the towers, but they belong to the same long grammar. Water below, water above, mineral between. If you were to follow that grammar one step further, the basin would begin to feel almost like an instrument tuned to thresholds. A little more inflow and shallow water spreads. A little more evaporation and salts concentrate. A slightly different mixing zone and carbonate once precipitated. A slightly different elevation, and one spring remained submerged while another emerged and fell silent. The entire landscape is sensitive to increments. That sensitivity is why it can preserve so much information in apparently modest forms. A tower need not be enormous to be meaningful. A low encrusted ridge can matter. A hollow at the base can matter. A slight difference in elevation across a cluster can matter. Everything depends on relation. And relation is easier to see now that the day has stripped away distraction. In low light, the basin reduces to essentials. Pale stone, darkening water, flat sediment, mountain outline, cooling air. The tufa belongs perfectly among those essentials because it is itself distilled process. No extra material, no ornament. Only the residue of mixing water, retained long after the liquid setting changed. That purity of cause and effect is soothing. It allows the mind to rest in sequence. Something happened here, and the shape before you is why you know. The record may be incomplete, but it is honest, and honesty in a landscape often feels like peace.